Hello and welcome to Mronal's Math tutorial, and in today's tutorial we are going to look at stationary points, and we will be also looking at some questions related to calculating a few difficult differentiation questions. Let's begin. So let's look at the first equation of the curve is given as y equal to kx to the power of half minus 4x squared plus 2, where k is a constant. We need to find dy by dx and the second derivative and give it in terms of k. It's also given that k is equal to 2. We need to find the coordinates of stationary point and determine its nature. Lastly, part C is asking us points A and B on the curve have x coordinates 0.2, 5 and 1 respectively. For a different value of k, the tangents to the curve at point A and B meet at a point with x coordinate 0.6. We need to find the value of k. A lot of things happening in this question. Let us try to evaluate. So we are having y equal to part A. Y is equal to kx to the power of half minus 4x squared plus 2. Let us find dy by dx. So dy by dx would be equal to, bring the power down. Remember the rule of differentiation. You bring the power down and take away 1 from the power. So this is going to be k times half. So I can write it as k over 2. X to the power of half minus 1. Half minus 1 minus, bring the power down. So this is going to be 8x to the power of 2 minus 1, and differentiation of a constant is 0. So this simplifies to x to the power of minus half. Minus 8, 2 minus 1 is 1, so no need to write the power. So this is your dy by dx. To find the second derivative, you differentiate again. So the second derivative is going to be d square x over d square y over dx square. Again the same rule, bring the power down. So now we have k over 2, which is being multiplied by minus half. Okay, we'll simplify it later. X to the power of minus half minus 1 minus 8x. Remember, the differentiation of x is 1. Differentiation of a constant is 0. So that's why we had a 0 here. Now if you're having 1, differentiation of x is 1. So it's going to be 8 times 1. So let us simplify this. This gives me minus k over 4 x to the power of minus 3 over 2 minus 8. This is my second derivative, which is answer to part A. Now it is given to us that k is equal to 2. We need to find the coordinates of stationary point and also find the nature. Now, stationary point, at stationary point, dy by dx is equal to 0, and the nature would mean whether it is a maximum or it is a minimum. So for that we need the second derivative. We have to look at the second derivative. So let's start by substituting k equal to 0 and then putting the condition for stationary point, that means dy by dx equal to 0. So now part B, we have k equal to 2, and let's substitute that in our dy by dx. Dy by dx is equal to k over 2 x to the power of minus half minus 8x. Let's substitute that. So 2 divided by 2 is going to give me 1, and all that is equal to 0. dy by dx is equal to 0. So this gets simplified. and we are left with x to the negative half minus 8x equal to 0. Got to remember that if you're having the power is negative, yeah, if the power is negative, the easiest way to solve over here would be to try and make it positive. So what I'm going to do in the next step is I'm going to write this as 1 over x to the power of half minus 8x is equal to 0. Move the 8x to the other side. So we have x to the power of half is equal to 8x. Now if you have fraction on one side, make the other side fraction by putting a 1 there and cross multiply. So if you cross multiply, you can see that this is going to get multiplied too. This will multiply over here. So 1 is going to be equal to 8x times x to the power of half. So apply the rules of indices. So 1 plus half is 1.5, which in fraction is 3 over 2, right? So 1 over 8 is equal to 3 over 2, x to the power of 3 over 2. So take the root on both sides. So if you're having 3 over 2, you're going to take, to cancel this, you're going to take 2/3 root on both sides, 8 to the power of 2/3. Only then this will get cancelled. Yeah. So x is going to be 1 over 8 to the power of 2/3, which is equal to let us calculate that. One over 8 to the power of 2/3. This is equal to 1 over 4. So we get x is equal to 1 over 4. This is the only answer. Okay. Now we need to find the coordinates of the stationary point, and we also need to find its nature. So when it says coordinates, we need to also find y. So y would be equal to, that is going to be, you substitute in your original question, which is this bit over here. You're going to substitute in this one. Let's just copy that down. So this is y equal to, y is equal to k x to the half minus 4x squared plus 2. So let us substitute the k as well as the value of x. So 1 over 4 to the power of half minus 1 over 4x squared plus 2. So this works out to be 11 over 4. So the coordinates of stationary point are x comma y, which is 1 over 4 comma 11 over 4. Now we need to verify what is the nature of this. Second derivative is this bit. Let's copy it. This is your second derivative. Now we need to check the conditions for stationary point. What are the conditions for stationary point? If the second derivative is less than 0, right? So this is going to be a maximum at that point. And if the second derivative is greater than 0, then it is going to be a minimum at the given point. So we need to substitute our x coordinate. So we're going to substitute x equal to 1 over 4 in your second derivative. So the second derivative is equal to k is 2, 1 over 4 to the power of negative 3 over 2 minus 8. Let us work this out. How much is that? And then we can confirm whether it is a maximum or a minimum. This works out to be negative 12, which is less than 0. So we can conclude that it is a maximum at 1, 4, 11 over 4. Remember, it is very important that you need to mention this point. It is a maximum, and what are the coordinates? Without the coordinates, you may not get full marks. So you must mention the coordinates over there. All right then, that's about it for this question. Part B. We found the nature of the stationary points. And let's look at part C. The points A and B on the curve have coordinates 0.5, 2, and 1 respectively. For a different value of k, the tangents to the curve at point A and B meet at a point where the x coordinate is 0.6. Find the value of k. Alright, so now here we are having, let's say the curve is like that, and you have two points A and B. Okay, there are tangents to these points. Let's say these are the tangents, somewhat like that. Excuse my drawing. Let's say it's like this. Okay, these are the tangents at points A and B, right? So these are at points x equal to 0.25, and this one is at 1, A and B, and these meet at a point where x coordinate is 0.6. okay, so let's say point P. The x coordinate of this point is 0.P. We need to find the value of k for it. Alright, so we need to first calculate what is the equation of tangent at these points. They meet, so we equate them and then attempt to find the value of k. Alright, so let us now try to find the equation of tangent at the 2 points. Alright, so we have dy by dx already. So I'm just going to find the gradient using dy by dx. So dy by dx is this bit. Let's copy that. So we are doing part C. So at point A, we have the x coordinate is equal to 0.25, and at point B, the x coordinate is 1. So 0.25, and is it 1 or? Yeah, it's 1. All right. So we have these two things. We need to find the equation of tangents, and we also need to know what is the y coordinate when x is this. So let's use the dy by dx equation and try to calculate the gradient at these 2 points. So I'm just erasing the arrows which I had marked for the previous one. All right, so dy by dx would be, we don't know the value of k, that's what we need to find, We know the value of x is 0.25 to the power of minus half minus 8 times 0.25. Calculate that. And here as well, the value of x is 1 to the power of minus half, 8 times 1. Let us calculate this. So in this case, on the calculator, you can only calculate what is 0.25 to the power of negative half. So that gives you 2. So k over 2 times 2 minus 8 times 0.25 is also 2. So this is k minus 2. That's your gradient, k minus 2. And here 1 to the power of negative 0.5 is 1. So you're going to have k over 2 minus 8. That's the gradient for at point B. Now let us calculate the value of y. Y is equal to 0.25. So what's the equation of y again? We have it here. Let's copy it from here. It's the same thing which is given at the start. Use that. And now we attempt to find the value of y when x is 0.25. Just substitute. And here it is going to be 1. Again, you can use the calculator for 0.25 to the power of half this time. It's half, so it's going to be k over 2 minus 4 times 0.25 square. That is 1 over 4 plus 2. So minus 1 over 4 plus 2, that gives you 7 over 4. This is the value of y. Okay, on this side, we have y is equal to k minus 4 plus 2, which is k minus 2. So now we have x, y, and we have also the gradient, right? So let us write the equation of tangents. Equation of tangent at A would be y minus y1 equal to m into bracket x minus x1. Your y1 is this thing. Remember, there are two terms, so put a bracket in the front. Is equal to m, which is again k minus 2, x minus 0.25. Right? And on this side, the equation of tangent would be then at B would be y minus y1, which is my k minus 2. M is k over 2 minus 8 x minus 1. All right, this requires a slight simplification. It was going to be easier if you just rewrite this as y equal to, just move this entire thing to the other side. If it's minus, it's going to be plus. So y equal to k minus 2 times x minus 0.25 plus k over 2 plus 7 over 4. And the same thing I'm going to do on this side. Try to move this one, which is a minus, to the other side. So that's going to be k over 2 minus 8 x minus 1 plus k minus 2. Okay. Now we know that when they meet, these two are going to be equal. They meet at a point where x is 0.6. So I'm going to make these two equations equal to each other, and I'm going to substitute the value of x, because I already know the value of x. When they meet, what is the value of x? Okay, so substitute x equal to, it's given to you that they meet, when they meet at a point where the x coordinate is 0.6. So we're going to substitute the x coordinate, which is 0.6 over here in this case. So that's going to be then k minus 2. So you notice that I did not expand, because if you expand, you're going to complicate over here, because eventually you just have to calculate k. So, and we had the value of x. So when I substitute the value of x over here, it becomes much easier, because then I have to just calculate this bit, which is 0.6 minus 0.25. In other case, if you had expanded, it would be a lot of things, and you will lose your time in trying to simplify. So this is 7 over 20 plus k over 2 plus 7 over 4 equal to k over 2 minus 8 times 0.6 minus 1, which is negative 2/5, plus k minus 2. Right? Now let's just expand these two, and then we just collect all the like terms. So 7 over 20k minus 7 over 10 then, plus, because I multiplied 2 with 7 over 2, so 2 divided by 20 is 10, k over 2 plus 7 over 4, and the same thing here. When you multiply, you're going to get negative k over 5 plus 16 over 5 plus k minus 2. Alright, so I'm just going to now try and collect all the like terms. So I'm just going to underline the terms without k and put them on one side. So 7 over 20 k plus k over 2, then move this one to the other side, yeah, plus k over 5 minus k is equal to 16 over 5 minus 2, and these two we move to the other side, plus 7 over 10 minus 7 over 4. Alright, now it's just a matter of adding up. So, okay, as a common factor, you have this, this works out to be, on the right hand side, it works out to be 3 over 20, and this one works out to be, let's see what it is, 7 over 20 plus half plus 1/5 minus 1. This is 1 over 20. So k times 1 over 20 is equal to 3 over 20. So k is equal to 3 over 20 divided by 1 over 20. That is going to be equal to 3. So the value of k is 3. Although this question required a lot of algebra, it was not that hard, but you did have to find the equation of tangents for both, and the total marks for this question would be 12, right? Alright, then that's it for this question. Let us look at a second question. The equation of the curve is y equal to fx, where fx is 4x minus 3 to the power of 5/3 minus 20 over 3x. We need to find x coordinates of the stationary points of the curve and also determine their nature. Now here, this question is interesting because not only you are learning the concepts about stationary point, finding their nature as we did in the previous example, also because you're going to make use of chain rule to differentiate this. So let's begin. So we have fx equal to 4x minus 3 to the power of 5/3 minus 20 over 3x. Let's differentiate. So bring the power down and take away 1 from the power. So that is going to be 5/3 minus 1. Multiply by the chain rule. The chain rule means differentiate the bracket. Differentiation of 4x is 4 minus a differentiation of 3 is 0. So 4 minus 0, we can straight away write over here 4. So times 4 minus 20 over 3 times 1. Let us simplify. That gives me 5/3 4x minus 3 to the power of 5/3 minus 1, which is 2/3. And then this times 4, can I just multiply 5 times 4? That gives me 20 here. Yeah. So 5 multiplied by 4 gives me 20. Minus 20 over 3. This is f prime of x. At stationary point, dy by dx is 0. So f prime of x is equal to 0. So we make this equal to 20 over 3. 4x minus 3 to the power of 2/3 is minus 20 over 3 is equal to 0. Move the 20 over 3 to the other side. That gives us equal to 20 over 3. The 20 over 3 on both sides could cancel off. Now we are left with 4x minus 3 to the power of 20 over 3 is equal to 1, not 0. Because 20 over 3 divided by 20 over 3 is 1, not 0. So to cancel off 2/3, we do to the power of the reciprocal, 3 over 2 on both sides, power of 3 over 2. So this cancels off. So we get 4x minus 3 is equal to 1. 1 to the power of 3 over 2 is just 1. That gives us 1 plus 3, or x is equal to 1. So we just had to find the x coordinate. And now we need to find the nature of the stationary point. So for the nature, we need to find the second derivative. We have the first derivative, which is over here. Let's copy that. The second derivative would be then, again differentiate for the second time. You can write d square y by dx square, or you can put a double prime. Bring the power down. So we are going to have 20 over 3 multiplied by 2/3. 4x minus 3 to the power of 2/3 minus 1 times the chain rule. Again, differentiation of the bracket. 4x minus 3 is nothing but just 4. Minus differentiation of a constant is just going to be 0. So let's simplify this. That is going to be 40 over 9. And we also have this is 40 over 9 and this times 4. So that becomes 160 over 9. Can we write that? 160 over 9 times 4x minus 3 to the power of minus 1/3. 2/3 minus 1 is minus 1/3. This is the second derivative. Now you substitute. X is equal to 1. The second derivative works out to be 160 over 9 times 4 times 1 minus 3 to the power of negative 1/3, which works out to be 160/9, which is greater than 0. That means this is going to be a minimum at x is equal to 1. Alright then, that's about this today's video. We have seen stationary points. What are the conditions for stationary point? We have seen how to find the second derivative. We have also seen how to apply the chain rule. If you have liked the video and would like to see more tutorials, remember to subscribe to my channel, Mrinal's Math Tutorial. Thank you for watching.